So today we're going to cover section 2 from chapter 5, and it's going to be on congruent polygons. This lesson is leading us into what we're going to actually be doing in the entire chapter, and that's more specifically talking about congruent triangles. But today we're just going to talk about polygons in general. So first let's define what a congruent figure is. And a congruent figure are two figures that have the same size and the same shape. All of the corresponding parts of one figure are going to be congruent to all the corresponding parts of the other figure. So we'll be able to match all the angles and all the side lengths. They may ask you to match every single corresponding part. And then you will also probably be asked to write a congruency statement or a statement of congruence. So as soon as everybody's done copying this down, then we're going to go through and we're going to identify all the parts that are congruent in these two triangles. All right, so if they are asking you to write and show all of the corresponding parts that are congruent, we're going to, when it's a triangle, we'll be able to find 3 angles that match and 3 sides. So let's do the angles first. So I'm going to start with my left triangle, and I'm going to say that angle A, because it's got the single mark there, it's going to match with angle F of the triangle in the right. Then I could match the one with the 2 markings, angle B, and it's going to match with the same type of marking in the right triangle, and that's angle E. And then the last angle is angle C, and it's going to match with angle D. So when you have congruent figures, you should be able to match all of the corresponding parts. So far we've taken care of the angles. Now we're going to do the same thing for the sides. So I have side AB, which has 1 congruency mark. And then I'm going to look for the same type of marking on the right triangle, and that is going to be FE. And then my next side that I could match could be AC. And it's going to match with FD. And then lastly, the one with the 3 lines, BC, is congruent to ED. So this is the type of answer you would provide if they ask you to match all of the corresponding parts. Now, you might also be asked to write a statement of congruence. When you write your statement of congruence, the order of the letters matter. So more than likely, you would be started out with the triangle on the left. And now we have to match in the exact same order for the second triangle. So I could say that triangle ABC is going to be congruent to FED. In the order of that second triangle, I couldn't put it as EFD or DFE, it has to match. So for example, notice the A and the F are in the first spot. So those are the 2 congruent angles. And that's what I had here. And then the same for the second, the middle letter. It's going to match with the middle letter here. And that was my second corresponding part that I showed was congruent. And then lastly, the C, which is the last letter, matches with the last letter in the second triangle, and that was this statement. Notice for the sides, you could sort of set up the same thing. Notice how AB are the first 2 letters here. I'm going to do it in pencil, like AB, and it matched with FE, and that was the statement I put here. Or let's say you did the last 2 letters, BC, and it matches with ED, which was this one. And then if you did the beginning to the end to make your side, that was the middle one. So the order of this statement is going to be very important. If it is not written in the precise order, you will get these questions wrong. The next slide is a theorem, and it's called the third angles theorem. And what this theorem states is if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. So notice in this picture, angle A and angle D have the same mark, indicating that they're congruent angles. And then I also have a mark with B and E. So automatically, if you already have two pairs that are shown congruent, then you can automatically conclude that this last set is also congruent. So if you were writing this in a proof, the reason would be the third angles theorem. The next slide is talking about properties of congruent triangles. And we've already seen these properties. We saw them with variables, angles, segments, and now we're going to see them for triangles. So the reflexive property for any triangle, this would be, for example, if it was triangle ABC, you could say that triangle ABC is congruent to triangle ABC. Any polygon is always congruent to itself. So again, reflexive, like the reflection looking in the mirror. Symmetric property of congruent triangles, remember this is like a line of symmetry that would go through the word then here. And then if you were to fold it up, notice how the triangle DEF matches here. And then the triangle ABC, if you were to fold it up, it would match. And then the transitive property, remember this is like where we would cancel out the triangle DEF. And then from there you could conclude that ABC is also congruent to JKL. So same three properties that we've seen before, but now we're applying them to triangles. If you've already finished filling this in, take a look at the next slide. It is 5 questions where you're filling in sometimes, always, or never. See if you can fill those in while we wait for everyone to catch up. Let's try the next one. So we're going to complete these with the words either sometimes, always, or never. So here again, remember when we have congruent triangles, every angle needs to match. So here it says an acute triangle is blank congruent to an obtuse triangle. Well, you should realize that an acute triangle has all 3 acute angles. An obtuse triangle would have 1 obtuse angle. So there's no way that these could ever be congruent. So this would be never. The next one, a polygon is blank congruent to itself, and this would be always. So a polygon is always congruent to itself because it's the same size and the same shape. A right triangle is blank congruent to another right triangle. This one would be sometimes. The only thing that it would have in common here is that it would have a right angle, but the other 2 angles could be different. So this would be sometimes. For example, you could have a right triangle here, and let's say this one's 30 and this one's 60, but then we could have another one, and this could be 45, 45. It could be isosceles. So they're both right angles, but they don't have the same other 2 angles. So this would be a case when it wouldn't work, or you could have 2 triangles that would have exactly the same information. The next one, if triangle ABC is congruent to XYZ, then A is blank congruent to Y. Now remember how I showed you how everything matches? So remember, A would match with X, and then B would match with Y, and C would match with Z. Now, this is a trick question. at first glance, you're going to think, well, A is supposed to always match with X, but what if we had an isosceles triangle? So like, for example, here, let's say this one was ABC, and then this one is XYZ. In this case, A is going to be congruent to X, and it's going to be congruent to Y. So this would be the case when it's sometimes, or it could be totally different. So this answer is sometimes, and the sometimes is when it's an isosceles. Now, I just showed you the matching here. So here it says if ABC is congruent to XYZ, then A is blank congruent to X. Well, if we use this little mapping like thing, we're going to see that A is always going to be congruent to X. It's only sometimes to either Y or Z. All right, so here they're telling us, because they gave us this statement here, that these two quadrilaterals are congruent. And again, remember, we can use this like mapping thing where you can see that A is going to match with F, B is going to match with G, and C is going to match with H, and then lastly, D is going to match with K. Now, whenever you are having these figures and you're not sure what the expression or what the numbers are pointing to, remember when it's got the little circle at the top, that's referring to a degree. If it's got a linear unit of measure like inches or centimeters or feet, that's referring to a side length. Now it wants me to find the value of X. This is where my congruency statement is going to come into play. Now, these pictures are nice and pretty. They're sitting the same way, so it's easy to see which sides match. So I can see that this side here, GF, matches with AB. Now, if maybe it was flipped upside down and it wasn't facing the same way and you couldn't see what matches, this is where you use the statement and you can see what matches. So if I wanted to use AB, I'm going to match it with FG, which is also the first two letters. So now to find the value of X, I'm going to set them equal to each other because corresponding parts of congruent figures are congruent. So let me go ahead and write my equation. The equation I'm going to use is I'm going to set AB equal to GF. So I'm going to do 3x minus 6 equals 9. I'm going to add 6. 3x equals 15. Divide by 3, and x equals 5. Now that I found the value of x, that x value is going to be the same that I could use to plug in for fk. So I'm going to come over here and notice, not fk, sorry, angle k. So notice the next expression that has the y in it is over here. Notice it's got the little degree symbol and it's pointing right here. So this is going to be the measure for angle k. If I go back to my statement, I can see k is over here, the last letter. So I'm going to match it with the last letter over here. And angle D equals 44. So this is how I'm going to set up my equation to find y. I'm going to take 4x plus 2y and set it equal to 44. Now you may think, how am I going to solve this? I have two letters. Well, we already found, yes?
No, I was just going to ask you that, like, if you're supposed to put the 5 into.
Yes, you are. Thank you. So we are going to take this 5 that we just solved for, and we're going to plug it in for x. So we're going to do 4 times 5 plus 2y equals 44. I can multiply the 4 times 5 equals 44. And then now I can move the 20. And I get 2y. And then I'm going to subtract. And I get 24. Divide by 2. And y equals 12. Okay, so for example 3, it says Maggie took the piece of fabric STUV shown in the diagram and cut it on the diagonal to make a scarf for her and her friend. Are the two pieces the same size and shape? Explain. So what we're going to do here is we're going to make sure that all of the corresponding parts are congruent. So what we can do is match everything. So notice here, let's go and do the sides first because they all seem to be marked. So we could say that SV, do a different color here. So SV is going to match, see how it has one mark here? It matches with TU. So we'll say SV is congruent to TU. And then I can do the side that has two markings over here. ST is congruent to VU. And now this diagonal here that goes through the center, it's the same for both pieces of scarf or both triangles. This is where I'm going to use my reflexive property, and I'm going to say that SU is congruent to SU. And that's my reflexive property, if you needed a reason why you would say that. We're going to be doing this in our proofs. Now what we need to do is go back and make sure all of our angles match. So we could say that angle T and angle V match because they're both right angles. Now, what we're going to do is these two lines are going to be parallel here and here, or even here and here. So then this is my transversal. So then I can say all the other pairs are going to be alternate interior. So like, for example, I could say this angle, angle 2, is congruent to angle 3 because they're alternate interior angles. And then I could say angle 1 is congruent to 4 because they're alternate interior. So I would say angle 1 congruent to angle 4 and angle 2 congruent to angle 3, and the reason is because they're alternate interior angles. So now I've just shown you all three sides and all three angles match. So now I know both scarves are the same size and the same shape. This is one scarf, and then this is the other one. Try practicing a proof. We will be proving a lot of triangles congruent in this chapter. Now, whenever you're given a picture and you're given some given information and the picture isn't labeled with the given, my recommendations to you are to go through and label everything that's given to you. So I was given that SV is congruent to RV, and that TV is congruent to WV, and ST is congruent to RW, and angle T, this angle symbol should be over here, is congruent to angle W. So I have this one and this one. All right, so that's all given to me. So let's go ahead and start this out. So statements over here. And reasons. So I'm going to restate all of my given. So I'm going to say SV congruent to RV, TV congruent to WV, ST congruent to RW, and angle T congruent to angle W. All four of those were given, and I'm just going to write it down all in the first statement. Now, whenever you have this bow tie looking thing, generally what you're going to usually need to bring into your proof are the vertical angle pair. So we have a pair of vertical angles right here and right here that are congruent. Now, I can't just say angle V is congruent to angle V. I need to use 3 letters. So I'm going to state that angle TVS is congruent to angle WVR, and that reason is the vertical angles congruence theorem, and you can abbreviate that as VAT. Now we just learned a theorem that stated that if 2 angles were already congruent, then we can automatically show that that third angle is also congruent. So now I could also state that angle S is congruent to angle R, and my reason is the third angles theorem. So angle S is congruent to angle R, and this reason is the third angles theorem. And now I can finally prove that my triangles are congruent because I've got markings now on every single angle. Let me add in that one I just said. S is congruent to R. And now all 3 angles are marked and all 3 sides are marked. And now the order of this statement is important. But again, they gave it to me at the beginning. So I can now say what I was trying to prove up here, that triangle STV is congruent to triangle RWV. And that reason is definition of congruent triangles. Or definition of congruent polygons, because we've shown that every single piece matches all 3 angles and all 3 sides.